Okay, so like I said, this is just going to be a review kind of over all the naming that you guys should have down up to this point, okay? And if you don't, just keep practicing, okay? But the couple things that I want to point out in this picture that you've got here is these charges that are listed right here, okay? Remember, those are kind of your guaranteed charges. Those are the ones that I am requiring you to be able to look at your periodic table and you know them. So group 1, 2, 13, and then 17, 16, 15. Remember, group 14 is our midpoint, so it kind of goes plus minus. You won't see that too often, okay? So, and then when we have our transition metals, do we know what their charges are? No, right? Okay. So, so today we are going to review how to come up with that. We kind of went over it a tiny bit yesterday, but we're going to go over it one more time today, make sure we've got it. So let's start with the basic stuff first, okay? When you have a metal name going first and then the name of an anion, what type of bond are we dealing with there? What is it? Ionic. There we go. Cool. Okay. Okay. The particle that you have just created is called a compound. It's just an ionic compound. Okay. It does not get called a molecule. And sorry, jump back up to bond. That's where I needed to put it. The ionic bond is called an electrostatic force. Okay. Or a coulombic force. And that's just going back to that Coulomb's law where you had two charges a certain distance away, they're attracted to each other because they're positive, negative. So I do want you to start kind of using that electrostatic idea because that's all that's happening here. Just like your protons are attracted to your electrons, this positive thing is attracted to this negative thing, and they form this compound, okay? Those compounds then join together because they're all positive and negative, so it's kind of like you have like a row of positive, negative, positive, negative, positive, negative, and then another row of positive, negative, positive. It just kind of keeps going. And what that forms with all those compounds is called a lattice. Okay, and we're going to go into more details with that later when we actually start talking about the ionic properties. All right, you guys do know that an ionic compound is always between what and a what? A what? True. Just kidding. Well, okay, so what are we looking for on the periodic table? A metal and a non-metal. Okay? But I am okay putting cation underneath this one and an anion underneath that one, because that is really what it is. Something that has a positive charge, something that has a negative charge. Okay? We also saw that we can have those metals combining with a blob, right? Those polyatomic ions. So that would be your nonmetal anion thing, okay? All right, so let's do a little bit of practicing. So the calcium chloride, what is the approach that you take when you look at this name? Find their charges. Good. So you've already verified. You said calcium's on the left-hand side, chlorine's on the right-hand side. That's ionic. So now I need to look at their charges. So let's find calcium. What's the symbol for calcium? Ca. What is the charge on calcium? It's a 2, so plus or minus? Plus 2. Good. Chlorine is a what? Good. -1. We take those two charges and we crisscross them, like we've learned. And that says calcium and 2 chlorines. Okay? So remember, why did we even crisscross those? What is the ultimate goal of your ionic compounds? They have to equal 0. So what this says is 1 calcium needed 2 chlorines to make it electrically neutral. Okay? Or a net charge of 0. All right, sodium and sulfur. So sodium is Na. What's its charge? +1. Sulfur, S. -2, good. Crisscross those, we get Na2S, sodium sulfide. All right, lithium bromide. So lithium is Li. What's its charge? Plus what? plus 1. It's in group 1. And then bromine is in group 17, so it's a minus 1. Crisscross those. Do we need any subscripts? No, we're just going to put LiBr. So 1 lithium for every bromine. So that's one that would look like positive, negative, positive, negative, positive, negative, and then another row of it. And that creates a salt. All right, that lattice is also, it looks like a salt to us. Okay, these little crystals. All right, aluminum iodide. So we got aluminum, that is Al. What's its charge? It's in group 13. Plus 3, good. And then iodine is in group 17, so it's 1 away, minus 1. Okay, we crisscross those two charges. We get Al-I3. Okay, any questions on that? I feel like that one you guys don't really have many issues on. When I looked over your quizzes, that part you didn't do bad on. The part that we need to look at is making sure we know how to name them. Okay, because a lot of people wanted to put some prefixes in there. Do we ever put prefixes on our ionics? Never. All right, so looking here, we see a metal, and then we see a whole bunch of nonmetals, right? So what is this thing called? Not what is its name, but what is a blob called? A polyatomic. Good. All right. Okay, so go look up that one. Who is that one? Because we have sodium. Acetate, good, and that's all we write. Nothing special, you just write their names. Okay, then we have lithium chloride. The next one, if you were not experienced, you would look at it and be like, oh, that's nonmetals with nonmetals, that's covalent. This is not true, right? What do we know this guy is? Ammonium. Good. So this is ammonium. And what is the CO3? Carbonate. Good. We are going to learn about something called ammonia, and that's NH3. So make sure you don't get those guys confused. All right. And then finally our last one, we've got aluminum oxide. Good. All right, real quick, go back to ammonium carbonate. Where did that 2 come from? In the middle?
Oh, that's the charge carbonate.
That's the charge on carbonate. So we crisscross their charges. Remember, that's how we're coming up with these formulas. All right, so the basic ones, we're good. Let's go ahead and review now the Roman numeral ones, the ones that everybody loves so much. Okay. All right, so over here we have a metal name goes first, so the charge, Roman numeral, then the name of the anion. All right. So what type of bond is still going on here? This is still an ionic bond. Good. Which means it's still electrostatic. Does everybody know what a static electricity is, by the way? You guys know that if you rub a balloon on your shirt, you can make a stick? It's because what you're doing is you're peeling off some of those electrons, and one becomes positive, the other one becomes negative, and they stick. Same thing with these cations and anions, okay? It's just static electricity. What? Oh. All right, your particles here, they are still going to be compounds, and they're going to form a lattice if you have more than one. Remember that lattice just looks like a crystal does. All right, and then they are between a transition metal or a multivalent cation. You don't have to write that if you don't want to. But typically they are our transition metals and some sort of a nonmetal or polyatomic. Okay, so still cation, anion. So looking here, writing the formulas. All right, so this guy goes here, by the way. Sorry, yeah, there's a lot of little typos on this. But looking here, we have tin 4 fluoride. All right, so look up, what is tin's symbol? SN, good. What does that 4, that Roman numeral 4 mean? Let me get more than 2 people answering that one. What does this 4 mean? Does it mean there's 4 tins, or does it mean it has a +4 charge? There you go. All right. I expect more answers on the next one. Okay, so it has a +4 charge. And then we have fluorine, who's in group 17. So what's its charge? -1. Crisscross those guys, we get SnF4. Okay, biggest mistake that I keep seeing is that 4 people like to think is the subscript on the tin. All right, they think that that's the number of tins. That's not true. That is its charge. You still are crisscrossing. Okay. All right, lead to oxide. Go look up what lead is. Or you already know it. PB, good. Peanut butter. All right. That little Roman numeral 2, what does that stand for?
Positive charge of 2.
Positive charge of 2, good. And then oxygen we know has a what charge? -2, good. We crisscross those guys. Do I have to write any subscripts? No, because they cancel out. Okay. What we're going to look at down on the bottom, though, is that you have to be able to look at this and tell me that it was lead, too. Okay? So we're going to practice that at the bottom. But who remembers what the basic thing was? Who did we look at? Did we look at the lead or did we look at the oxygen to get our answer? Oxygen. Oxygen is your guarantee. Remember, that's what I said up here. Those 3 right here, these guys are really, 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 really helpful because they don't really change. Okay? So you use those to always figure out your Roman numerals. Got it? Got it. Woo! Okay. All right. So looking at the next one, copper 1 nitride. So we're going to say copper. What does that 1 mean? +1. Nitrogen has a what charge? -3. Good. Okay, so just in case you're still struggling with that, how far away is it from a noble gas? You do little bumps. It's 3 away. Okay? All right. You crisscross those charges and you get CU3N. Good. All right, next one, iron 3 sulfide. So iron is Fe. The 3 means +3. Sulfur has a what? -2. Crisscross, you get Fe2S3. Okay, and once again, you have to be able to look at these guys and know what their charges are. So that's what we're going to practice now. Look at the bottom. Okay, we're going to write out the steps, okay? Your first step is to always look at that anion, okay? So your first step, look at anion. I'll put charge on there too. You need to know what its charge is, okay? So for this one, we have chlorine. What is chlorine's charge? Ooh. It's in group 17. -1, good. Okay, so your second step, overall negative charge. That's your second step, okay? So overall, we have a -1 and there are 2 of them. So what's your overall charge? What is it? -2. Okay, so your third step, sorry, I'm totally taking up a room down here. Your third step is net charge is equal to what? What do we need it all to equal? Equals 0, okay? Sometimes it's really easy. Sometimes you got to do one extra step, which we're going to see in the next one. So this one is not too bad, right? If it is a -2, what does this 1 tin have to be? +2, good. So we're going to call it tin 2 chloride. All right, your next one. This is one we're going to have to think. I'm going to write it down here because I just don't want to confuse y'all. So I'm going to write it down here. All right, so Cr2O3. So who do we look at first? Oxygen, good. So oxygen has a what charge? -2. What's my overall negative charge? -6, right? We have a -2. There are 3 of them. So overall, I have -6 totally, right? Last step, we need our net charge to equal 0. So what does this number have to be? Well, what does the number have to equal? It has to equal a +6, right? But there's 2 of them. So what kind of math do you do? What kind of math do you do though? You divide it, okay? So just in case it's not this simple and it's not always 2, divide them. Okay, so when you do 6 divided by 2, you know each one has to be a plus 3, right? So you got chromium 3 oxide. Okay, you guys try the next 2 and I'll show you the answer in 1 minute. Okay, here are your answers. Did you get copper 1 fluoride and lead 2 nitride? Yes? Good.
Like if it was just a 1.
Yeah, you still have to say it because you're saying it's copper 1 and not copper 2. Yep. Good question though. All right, real quick, I do want to show you the shortcut, but you got to be careful with the shortcut, okay? So let's say for this chromium 03, what you can also be doing is a reverse crisscross. Okay, and if I reverse crisscross, you now are saying chromium is a plus 3, oxygen is a minus 2. The last step that you have to do, though, if you use your shortcut, is you've got to verify that. Is oxygen a negative 2? Yeah, so then this works out. So it is chromium 3. However, if you had something like that PbO, right? If you have this, and I reverse crisscross, what is that saying both of them have? A plus 1 and a minus 1. Does oxygen ever have a minus 1 charge? No. This tells you you got to do it the long way. Okay? But you do have that shortcut. I always use the shortcut, but it is up to you. Okay? Long way is always good because you do the net charge equals 0. All right, so let's run through our prefix stuff. What is the mistake? Who can find it? What's the mistake? There's no 10. Yeah, they put penta twice. So this is deca. All right. Okay, I'm going to leave lights on. Sorry. So bond, if you have both are non-metal, so both of them are found on the right-hand side, what kind of bond is that? Good. No. What kind of bond is between 2 non-metals? It's covalent. The particle is we call a molecular compound. Okay, so we don't call it a covalent compound, we call it a molecular compound, aka the molecule. So these are your blobs. All right? These are the ones that require chemistry to break them apart. Your ionic stuff, I could just dump them in water and they break apart. All right? These you gotta do some chemistry to break the things apart. They will still dissolve, but they're gonna stay blobs in your water, if that makes sense, okay? And we're gonna look at that, I promise. I'm gonna show you exactly what it looks like. Because sugar dissolves, do you guys agree? Yeah. Does salt dissolve? Yeah, right? So one is an ionic one, the other one's covalent. So what we're gonna see is the ionic one splits apart. You have a bunch of sodiums and a bunch of chlorines. The other one stays those little blobs of sugar, but they happen to dissolve, and it's going to be something due to intermolecular forces that we'll learn next, okay? All right, so these are between a nonmetal and a nonmetal, and we use prefixes. Prefixes are our best friends, so this shouldn't take us too long to run through. So when you are looking at these, you are paying attention to their prefixes. So the first one you have iodine, heptafluoride. So there's nothing in front of iodine. What does that tell you the number is? 1. Hepta is 7. You gotta learn them. All right, so we got 1 iodine, 7 fluorines. That's it. All right, carbon monoxide. So I have nothing in front of carbon. How many? 1. How many is mono? 1. All right, so we have carbon and an oxygen. Notice we do not say monoxide. You chop off the beginning, or I'm sorry, you chop off the end of your prefix. You go monoxide, okay? Okay, we're going to get there. You leave it. All right, so for this one, we got diphosphorus. What is di? 2. What is tetra? 4. All right, if you notice, we chopped off the A in tetra because we start with an O. So it's tetroxide, okay? So this will be P2. 04. Next biggest mistake, people want to simplify that. You do not simplify your blobs. Your blobs are blobs for a reason, okay? The only ones you simplify are your ionic compounds because those guys have a net charge problem, right? So, all right, Octa Carbon. What does Octa tell you? 8. And Hexa? 6. Good. So C8S6. You guys can't see that, sorry. C88S6. All right. Next one. CCl4. There's only one carbon. Do I put anything in front of it? No, we're just going to write the word. So it's carbon. What do I do for 4? Tetra. Good. So tetra chloride. The next one, we have Bi3. So, anything in front of boron? No, we're going to put boron. And then it's triiodide. That one, you do leave the 2 vowels together. That's kind of a joke in AP chemistry. We're always like, triiodide, triiodide. I died doing that. It's just, I don't know. That's what we say. We're kind of nerds. You should join the family. All right. P2S3. Good. Diphosphorus. That was a long one. Trisulfide. And then finally, dinitrogen. Dinitrogen. Monoxide. Okay? So these aren't too bad, but you do have to know your prefixes. Okay? Do you guys have any questions for me on these? Okay.